If you'd like to see how to launch a custom NFT project with your own smart contract in about half an hour, more or less, from start to finish, then you are in the right place. Not only are we going to walk through how to code a custom ERC721 smart contract using OpenZeppelin and all the standards and all that stuff, I'm going to show you how to deploy it to the Polygon Mainnet so that it actually shows up on OpenSea and you can start selling it if that's what you want to do. So we're going to do that from start to finish. It's going to take us about half an hour. This is a workshop episode, which on our channel means that it's a little bit more freeform. It's kind of just working through the problems as we come across them. And yeah, if you like this video, if you find it helpful, I only ask that you give it a thumbs up at some point along the way. And if you really like it and you want to stay in touch with us and what we're doing, we put out content like this pretty much every day, so subscribe to the channel. With all that said, let's jump in. What's up everyone, Steven here from TechMaker Studio. In this episode, I'm going to show you how to pretty much set up an NFT project from start to finish. I'm calling this my Shapes project, which is really not that creative, but that corresponds to what this is here. So let's look at the images for these. So basically I just have a super simple set of NFTs here. These are just some images I made in Illustrator. It's just a triangle and a circle laid out in some different configurations. There's only 3 of them. Nothing too fancy. I do kind of like this one. So we're going to run through basically deploying this so that by the end of this, we will have deployed an NFT contract onto the Polygon network. You're going to pretty much understand all of the elements that are required to launch a project like this. It may take us a little while, we'll see. I'm going to put this into our workshop catalog, which means this is sort of more free form. I'm going to take my time. I'm going to do this right. I'm going to make sure that, like, you know, it's going to be quick, like, for all things considered, but I don't want to waste your time, but I don't want to rush through it either. So anyway, let's see, where do we go from here? The first thing that you're going to basically need 3 things up front before you can actually participate. You're going to need some kind of API, and if you don't have it, you can use mine here. Actually, I don't care. I'll put a link to this down in the description. If you want to use your own, which I suspect you will for a real project, there's actually going to be a link down in the description to a series we just released on how to set up an API with Node.js. So that'll walk you through pretty much all the things you need to set something like this up. You will need to know the OpenSea metadata standard, which you can find here, and you can read through that. But like I said, you can just use my URL to start. And some of you who have followed along with NFT projects might look at this and think, oh, what about like generative projects where we have generative art? Never fear. I actually have a couple of videos that explain how to use Python to generate randomized art based on probability distributions. I will link to those also down in the description. So follow along with this first. You'll get the idea of how the whole process fits together. And then dive in deeper into those other things once you want to build out your entire stack. So with all of that said, we've kind of laid the groundwork for what you need. We're also going to use a library called Truffle, and basically to install Truffle, I think that it's just an npm install. I haven't installed it super recently. They may have like a one-click download. Npm install -g truffle. So essentially we're going to use this. So you're going to need to have Node.js installed on your computer, and then you should have npm, and you should be able to install Truffle. So if we jump over into the terminal and we run npm install -g truffle, this will set up Truffle for us. Okay, so that did take several minutes for me, but once you've got it, you should be able to say Truffle version, and I guess I did get the version here. Probably don't need the truffle -- version. It's probably just version. That's what I'm gathering. Yeah, there we go. So I'm on 5.4.3.2. That may have upgraded my local version, so hopefully I didn't make any like unusual breaking changes by running that again, but we'll find out together. This will be fun. So anyway, basically I've got this Shapes NFT API right now. I'm going to make another one. I'm going to make a directory, Shapes NFT contracts, and we'll change down into there. And inside of here, I'm going to run truffle init, and that's going to initialize a new truffle project for us. And if we run ls, we'll see that we have a few directories and then a truffle config. So what exactly is truffle? The simplest answer to that question is that truffle is meant to be a set of tools that make developing smart contracts much easier. You can see we have 3 directories here. We have contracts, which is where, as you might guess, your smart contracts go. We have migrations, which is where we write scripts in JavaScript, which tell Truffle how we want to deploy things to the blockchain. So we'll get into that in just a little bit. That's how we'll deploy to Polygon, for example. We have to tell it, okay, this is what we want you to do. And then we have a test directory, which is where normally we would write a bunch of tests. And then we have our config file, which is where we specify all sorts of things like, you know, what private keys to use to deploy to which network and so on and so forth. So that said, we also need to initialize this as an Npm project. So I'm going to hit npm init-y, which is going to set up a package JSON. And then what I'm going to do is install something called OpenZeppelin. So we're going to say npm install at OpenZeppelin/contracts. So OpenZeppelin is a project, basically. Let's see here if I can get this open. OpenZeppelin contracts. These guys essentially have the kind of a golden standard, or whatever you call it, gold standard of open source contracts. So if you are familiar with ERC20 or ERC721 for different tokens, pretty much they've created, they didn't necessarily write the proposals like the ERC721 proposal or EIP 721 over on Ethereum or whatever. But they do write these open source sort of the code that meets those specifications that then everybody uses. So as far as I'm concerned, OpenZeppelin is sort of the standard for this kind of open source code. So the reason that we need OpenZeppelin is essentially because they've already written the fundamentals of this ERC721 standard. And ERC721, all this may sound super techno jargon right now, which is totally fair. But essentially this standard, this token standard, is what makes up most NFTs. So if we open this up, we can look down here and see like what all the functions of this implements. So an ERC721 contract, it has like balance of, owner of, transfer from, approve, get approved, so on and so forth. So essentially using this means that we're going to be compatible with all the systems out there like OpenSea and all this stuff. We don't have to stress about it. We don't have to write that code. The one thing that is interesting is we have this URI storage here, and you can see that when we have this contract game item, we're not saying it's ERC721, we're saying it's ERC721 URI storage. So if we come down and we click on ERC721 URI storage down here, essentially you can see that it's a ERC721 token with storage-based token URI management. And as I pointed out, like we have this URI that points to our metadata, so we're going to be using this. And this is such a thing where when we inherit from it, we also get all of the ERC721 stuff. So what I would like to do is try to actually go ahead and just set up a contract by copying all this stuff. So what I'm going to do is open up my code editor here, and let me blow this all the way up, close this, and zoom in quite a bit. That might be too much. Anyway, okay, so inside of here, we already have a migrations.sol. We're going to create a new file, and we're going to call this shapes.sol, and we're going to paste this in and save it. We're going to go ahead and change all the names. So this is shapes. This is shapes. Okay, so counters is an interesting concept. And again, we just copied all this code. I'm going to talk through it as we go. Counters is basically a special Open Zeppelin library that just counts. But what it does is it makes certain things a little bit easier. So you can call methods on this down here, like this token IDs.current, and it's going to tell you the current number. But then when we mint, or in this case, award item, which we're going to change this, the first thing we do is we increment. So instead of saying like, if you're familiar with like JavaScript or something, you might have like token IDs plus, if I can type, plus equals 1 or something. We can call dot increment. We don't have to get into what all the benefits of that are right now. Just know that like that's basically what it's doing. You can go read that code on the Open Zeppelin site. So we have a constructor, ERC721 game item. We're going to call this shapes, and we can have a thing of SHP. So this is the name of our token. This is the token ticker. And then award item, we're going to say, we're going to change this. We're going to, first of all, say it's public. I don't know that we need to return anything. And then what we're going to do is say there's a, actually, you know what? Let's just make this a function like this. Sorry, I'm kind of thinking as I go here. Purchase. It's going to be public, and it's going to be payable. Okay. Now, what we want to do is, so somebody's going to make a purchase. I'm going to line all this stuff up better. Okay, and then actually all of this is sort of too far back. Okay, there we go. So right now, this is calling we're incrementing the ID. So the ID starts off as 0. So when we initialize this up here, token IDs, we're setting a counter that's equal to 0. So the first thing we do, increment it, now it's equal to 1. We say the new token ID or the new item ID is 1, basically, because we set it to the current. Then we're minting, and we want to mint to message.sender. So whoever sent this message, we want to mint to them. And then set token URI. I don't really like this way of doing things. We're going to do this slightly different. So right now we have a purchase method that would actually work. We're going to need to change it a little bit. So let's just kind of start from the top here and implement a couple of custom things we're going to want. Let's say that we have a price, right? We have a price of uint 256, if I can type, price equals, and they're going to be 0.1 ether. Now this doesn't set this to literally 0.1 ether unless we deploy to Ethereum. What it's doing is it's setting it equal to 0.1 times the base currency, like whatever the native currency on the chain is. So if we deploy this to Polygon, it'll be Matic. If we deploy to Avalanche, it'll be AVAX. So setting the price like this says we're saying that the price is 0.1 Matic in this case. Okay, and then what we got to do is say require that message.value is greater than or equal to the price. Okay, and basically what this is doing is saying like, hey, this is a payable function, which we specify here. Make sure that whatever amount of Matic in this case comes along with this function is at least as much as the price. Okay, then we want to make sure that the tokens, actually let's do this down here. So we're going to start by incrementing, and then we're going to say require that token IDs.current is less than or equal to 3, because we only have 3 tokens available. Now, if you have, a bigger project or something, and you're building this out, you might pass the actual total supply in through the constructor or something like that and have it in a variable. In this case, I just know it's 3, and I'm just hard coding it here. Make sure that the token IDs.current is less than 3. Okay, new item is this, mint message.sender, new item, blah, blah, blah. So where are we in the universe? So we've got essentially our entire NFT contract functionality is brought in by this line, this ERC721 stuff. We initialize all of that in this constructor here, which really doesn't look like much, but it's essentially setting all this up. Then we've written a custom purchase function, which just has a price hard-coded. We're saying make sure that the message value is greater than or equal to the price. We are incrementing the token IDs, and so on and so forth. One thing that we need to do is right down here, we need to say, well, we need to do a few things actually, because we need to transfer this money somewhere that's being paid. And what we want to do actually is say payable owner, which we'll deal with in a second because we haven't gotten there, and say transfer and say message.value. Now this is going to be upset because we don't have an owner, and we're going to solve that by bringing in import at open, let's see if I can do this from memory, open Zeppelin contracts access ownable, if I can type. There's a decent chance I did not remember that correctly. Looks like I did. Okay, so if we save that, owner is still there. Let's go check out what's going on with our node modules, access, ownable. I think, okay, so what I need to do is say that this is ERC721 storage, and it is ownable. And now if we save this, this goes away. So what the heck is that? So what happens when we run the constructor and we inherit from ownable? It says whoever deployed this contract is the owner, and you can read about this in the ownable documentation. And then there's a method that queries who the owner is because of that. And then that just returns a simple Ethereum address. And if this is really confusing and complicated, it is really confusing and complicated. You're not wrong. It takes a little while to get your head around all of these things, which is why I have much more in-depth tutorials on the channel, and why we're going to be making many more of them. So subscribe, by the way, if you haven't. But essentially what this is doing, returning a regular address, and then we're wrapping it in a payable function call, which converts it into something that can actually receive money. And then we're transferring this message.value. If that doesn't make sense, try to take this away and save. And it's going to say send and transfer are only available for objects of type address payable, not address. So essentially what we have done is just set that up so that it's actually able to receive funds. One other hot tip while we're here, I made a mistake a long time ago in a smart contract that I wrote, and instead of saying message.value here, I wrote price. So we were transferring the price. And what can happen is, if for some unforeseeable reason somebody transfers more money than they should have into your contract, and you transfer the price, then the rest of their ether gets stuck in the contract and is locked forever, and you can't get it out. Somebody lost half an ETH because of a bug very similar to that in a contract I wrote a while back. So you definitely want to transfer the message value and not the price. Okay, so the last thing that we need to do is hook up our custom base URI. So if we go back over here and we go to ERC721 URI storage, you can see that we have this base URI. So what we want to do is write our own custom base URI. Now, what that's going to look like is something like this. So the reason for that is because we want it to pull from essentially what we want it to do. What we want to do is set our base URI to this minus the number. And then whenever the ID is out there, it'll automatically put that in there for the URL. It'll make sense in a second. So what we're going to do is say function base URI. And this is going to be public, and it's going to be view returns string. What is it over there? String memory maybe. And what is this? Overriding function is missing override specifier. That's right, because it's something we are inheriting from. Now what's it upset about? Maybe it's not public, internal maybe. There we go. Okay, so that's correct. Now what we want to do is just return, like I said, this here. And what is this saying? Function state mutability can be restricted to pure. And now that's, why is pure throwing an error? Oh, I need that to go away. Sorry, here we go. So internal pure override. Cool. So that seems to make sense. So what's going to happen here is whenever somebody calls the function, let's go back over to the code in. As you can tell, a lot of this is actually just knowing the ins and outs of all these libraries. But what's going to happen when we call token URI token ID? It's going to use the base URI, and then it's going to append the token ID to the end. So you can see that here, base URI for computing the token URI. If set, the URI for each token will be concatenated, the base URI and the token ID. So what it's going to do is it's basically going to say, okay, if the token ID is 1, then give us that. If the token ID is 2, then give us that. Again, like all of this is like fairly complex the first time you see it. It's really not that complicated, but it's really a lot of like just reading through all these libraries and getting a sense for what's going on. In any case, let's see if we can compile this. I'm kind of wondering if I'm going to need to switch my compiler or if it's good to go. This is a newer version of Truffle, so maybe it's okay. It looks okay. All right, so the next thing we need to do is set up a migration. So I'm going to create a new file, and I'm going to say to deploy NFT contract.js. And I'm being lazy, so I'm going to copy everything from the first file, which is just the migrations, and we're going to call this shapes, and we're going to require shapes. This is a Truffle thing where it's just like a handy way to require our smart contract code in here. So we're saying artifacts require shapes. And then module exports equals function deploy shapes. Okay. So we can do things which is like specify, the network and whatever, but essentially all I want to do is just deploy it. It's super, super simple, and I think that should be good to go. So I think now we've written the code to just deploy. I think I probably said something really confusing there. You can pass in other things like network here, and there's a specific, I think there's another argument, maybe it's like accounts, network or something. I forget off the top of my head. It'd be really easy to look it up. But the reason you would do that is you could say something like, if network is Polygon, do something specific, otherwise do something else. So that's pretty common in a lot of my code when I'm writing production projects. In any case, so I believe that's good. So the next thing we need to do is hook up our Truffle config to be able to deploy to a real network. So I'm going to grab some code from another project and just copy it in because it's going to be way easier. And so I'm going to pause the video and go grab that so I can paste it here. So actually, before I do that, I'm going to create, and I'm doing this literally just because I need to hide my screen here, because I'm going to deploy this to the real Polygon network. So I have to use a real private key. So I need to not have to put that on screen. So I'm going to create a new file and just call this like keys.js. And then I'm going to say module.exports equals an object. And I'm going to say private key. And then that's going to be something. And then I'm going to have another thing over here. It's going to be alchemy key. And that's going to be something else. Okay. So then back over in Truffle config, I'm going to say, let's see, const, and we'll say keys equals require, and we'll say ./keys.js. And then let's do console.log keys. So let's do like truffle deploy here. It's probably going to break, but it may spit out our answer here at the very top. So you can see right here we have, yeah, so it's not running because we don't have a client running and stuff, so that's fine. But you can see we have our keys being printed out here. So what this is going to let us do, and I'm going to go ahead and pause the video again and paste in some code and make a change so that I don't have to show my keys, but hold on 1 second and you'll see what I'm talking about. Okay, so actually, you know what? I'm going to remove some comments here. Actually, all of these comments just because they're in the way. So you can see we've got our keys that we're requiring. And then I have a network defined, Polygon, and actually we need to install this, and I have this copied ready. So we have HD wallet provider equals require blah, blah, blah. So what I want to do is say new terminal here, and I'm going to say npm install that. And hopefully that doesn't take a long time, but I'm going to go ahead and pull this down so I can keep talking through this. So basically, we're bringing in this HD wallet provider, we're bringing in our keys, then we have our Polygon provider, new HD wallet provider, private keys. We're passing in an array. Be careful about that. That has to be an array. You can set up a free Alchemy account on alchemy.com. It takes like a few seconds, and then get a Polygon Mainnet API key basically. I'm setting the gas price to 60 Gwei, I think, just eyeballing that. Okay, so let's just try this. Let's try to go truffle deploy network Polygon. So I have a wallet connected here that I put in my keys over here with a real private key that has a couple of Polygon in it. And let's see if this goes through. So deploying on these things, I should have checked the gas price right now. So far so good though. So we're deploying shapes now. This looks a little bit different than it used to. Okay, so you can see that cost. It's saying that it costs 0.015 ETH. It cost that in Matic, so you know, a couple of cents maybe. Looks like it deployed. Okay, so in order to interact with our contract, we need to verify it. So there's a library called Truffle Verify Etherscan or something like that. Truffle plugin verify. Okay, so I want to install this, and we're just going to kind of follow through here. So let's come down into our terminal, npm install truffle plugin verify. I'm going to assume that's going to work. Yep, there it goes. Add the plugin to your truffleconfig.js. So if I copy this and come down to the bottom, I think basically just down here anywhere, plugins. Let me make sure that looks right. Module.exports, yeah, at the very bottom. And then API keys underneath that. Okay, so what we have to do here is a little bit different. So, and this isn't actually, I haven't seen this documented anywhere. I just guessed and it worked. So you can see that we have Etherscan here. So all these networks have their own sort of version of Etherscan. And so if you go to Polygon Scan, you can set up your own key by just subscribing. So I have mine and I dropped it in my keys.js over here, which I'm not going to open. But it's now keys.polygonscan key. Okay, so what's the command again to verify? It's truffle run verify contract name and then network name. Okay, so we're gonna say truffle run verify and then it's shapes and then it's network polygon. And let's see, sometimes this takes a few tries to actually get it to work, especially if you try to do it right after you deploy. It's been a few minutes since we did it, so hopefully it works on the first shot. But let's see here. I guess I'm going to go ahead and pause the video while it finishes. So that took a little bit of time, but you can see down here that it passes and it's verified. And if we open that up, we'll see our shapes token tracker here. And then we've got our contract, which we can actually see all of the various things that we brought in. We can read the contract, so we can see we have all of these functions we did not write that came in from actually from the ERC721 from OpenZeppelin. And then we have a write contract, which we can approve here. So what I want to do is I'm going to switch to, I'm going to copy this link and I'm going to switch to a wallet in another window that has some Matic in it. So let's go to, I have a lot of freaking stuff. Okay, let's just go here. It's fine. So I want to write the contract and I want to, so how much Matic does this wallet have? This wallet has 4.84 and I want to run the purchase function. So I need to go 0.1. And if I click write, I'm not connected. I need to connect to Web3, MetaMask, and yeah, that one. And then if I click write, let's see, cannot read properties of undefined. Let's connect to Web3, MetaMask, purchase. I don't know what's going on with the gas. Maybe I need to crank up the gas. Okay, let's click that, view our transaction here. We'll give it a second. All right, so you can see that our transaction was successful. Now I don't want to bury the lead here. Let's go to OpenSea and let's go to my profile. Is this me? Let's connect this. And let's see here, profile. So I've got my one NFT here coming in, shape number 1, properties, got the description. Cool. So that's kind of magical. It just shows up on OpenSea. Let's have a look at what's going on in our contract. So if we come down here to token URI and we put in the number 1 and we click query, we'll see that we get back this lit sends blah 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 Heroku app all the way out to /1, which is what we had said. If we open that up, we see the metadata. I guess I have different like JSON viewers installed in my different like Chrome sessions. That's kind of funny. So what's happening is OpenSea is listening for events on these smart contracts on these networks. And once it picks up that, hey, there's a new ERC721 contract and there's a transfer event, which we can see here. I'm guessing this is how they think about this. Like it's transferring from this 0x000 to my address. It picks that up and then it says, hey, we should index that and add it to our site. So that's pretty cool. And we can go ahead and check. I forget exactly how much we said we had. I think it was 4.84. And so if we check on, I don't remember how much the other wallet had, so it doesn't really matter, but I'm assuming it got the 0.01. Let's actually do a quick double check. I think that was this one. It has 1.94. Let's do one more purchase here. Write contract. We're going to click write. We're going to edit this because I don't really want to wait. Save it and view the transaction. And let's see how long this looks like it's taking up here. It doesn't look like it's going super fast. Polygon can be really quick sometimes, other times not. Okay, it looks like it went through. Let me refresh here. Now it says I don't have a transaction. That's great. Okay, there we go. This transaction has been included, blah, blah, blah. So if we come over here and we refresh and go to, that's not what I wanted. I want to go to my portfolio. So now I've got shapes number 2 there. And we should have 4.64, and then we should have like a little bit over 2 in the real deployer down here. Yeah. Cool. So that's pretty much that. So what have we managed to do? So we went from basically just having this little API endpoint here, which again, there's some video links in the description on how to get that set up. And we have some images like this, which we haven't seen minted yet. I guess that's number 3. And we started with that, and then we basically wrote a custom smart contract using, admittedly, basically all of the code is from OpenZeppelin, and then we deployed that to a production blockchain. So that is on the Polygon Mainnet, and we did it all in like 30 or 40 minutes. So not too crazy. If you like this video, if you found it interesting, if you found it helpful, please give it a thumbs up. Help the YouTube algorithm figure out that this is quality content. And if you got any questions, drop them down in the comments. And as always, please subscribe to the channel so we can keep in touch. Anyway, I think that's pretty much it for this episode. So I will talk to you in the next one.